Today we are going to see about motion of rigid body, which is pure translational. So if you look into this diagram, we have considered the object at of the object at different times. But if you carefully see, it is the orientation of the object is not altered. So we are considering 2 points O and P, and the angle between this OP and with respect to horizontal we take it as alpha 1. Here again it is alpha 2 and here it is alpha 3. For all the cases it is 90 degree, or we can say that alpha 1 is equal to alpha 2 is equal to alpha 3 since I have assumed a reference in the horizontal direction. So in pure translational motion, even though the object is at different time instant at different position, the angle is not altered. Also, the velocities of different points of the object, of the solid rigid object, that is, if you consider O and P, the velocities of O and P is not altered at different instants of time. So in conclusion we can say that alpha 1 is equal to alpha 2 is equal to alpha 3. That is, the angle between say OP and this angle, this orientation will always, now we have considered vertically, even if you consider some other particle, then that angle, so similar same particle, the angle with respect to horizontal axis it is not going to change. For simplification, I have considered 2 points vertically placed with respect to horizontal. Therefore, I can say in this case it is 90 degree. Or the P point can be somewhere else also. In this case, if you measure, it can be more than 90 also. So in all the cases, it should be equal. That means angle should be equal of the particular particle with respect to some reference line. In this case I am choosing horizontal, and also that is alpha 1 equal to alpha 2 is equal to alpha 3, and the velocities of the particles O and P, or any particle in the object, solid rigid object, is not going to change. It is same everywhere. So in this case we can say the rigid body has a motion which is purely translational. Then we are going to consider another case, combination of translational and rotational motion. Now if you see the objects at 3 different instants of time, but if you see the axis of this object, it is not orientation keeps on changing. Now it is vertical, now this is tilted, and now this is horizontal. So in this case, this alpha 1 with respect to, let's say, a point P with respect to horizontal, this P point, if you consider this OP line, this angle is not going to be the same as with when you compare with pure translational motion. So alpha 1, alpha 2 and alpha 3 is going to change with respect to some reference line and the particular point that you are going to consider. For example, if you consider P and the horizontal line, in this case it is 90 degree. Now horizontal line is there, P is there. Now if you consider this one, alpha 2 is going to vary. Similarly, horizontal line is here and the angle from this line it is alpha 3. So in all the 3 cases we have observed that the angle is not same. That is, alpha 1 is not equal to alpha 2, which is not equal to alpha 3. And moreover, the velocities of the particles, say O and P, at different instants of time, it will differ. It is not going to be the same. So this is the second observation. Even though it is moving, sliding, so we can say it is a combination of translational as well as rotational motion. So the important points we have to remember is, if you consider some particles within that solid rigid objects, then if we make some reference line, say horizontally, So in that case, alpha 1, alpha 2 and alpha 3 is not going to be the same, it is going to differ. And also velocity of the particles within the object at of the particles is going to, velocities is going to differ for this case. So this case is about combination of translational and rotational motion. So far we have covered two basic motion. One is which is purely translational, where angle is going to be constant and velocity is going to be constant. And in another cases which is a combination of translation and rotational motion, where angle will differ as well as the velocity is not going to be constant. Velocity is also going to be differ. So keeping this in mind, hope you have understood about pure translational motion of a rigid body and combination of translational and rotational motion of the rigid body. Hope you have understood this topic. Thanks for watching. Nandri.